we talked about GUI, 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 micro ETH and milli ETH, and also ETH. So we saw just like normal currency, it has a denomination, yeah. And then we defined what are accounts. So, and we said there are two accounts. There are two types of account in Ethereum. We have externally owned accounts, and we have contracts accounts, a smart contract deployed to the network controlled by code. So this the smart contract address is normally controlled by code. So for the externally owned accounts, we see that they control account. They has a need balance. Someone can be able to send a transaction, either transfer or trigger a contract code is controlled by private key. So you need a private key, has no associated code. It is not associated to anything. It, it doesn't have any code that is associated to it. For contract account, we said that one can be able to see the ETH balance. It has a code associated to it. Code execution is triggered by a transactional message call received from other contracts, can also be able to communicate with other contracts. And the contract code is executed by Ethereum virtual machine on each node participating in the network. So this is a representation of Ethereum account. We have, these are normally the externally owned account, which has a nonce. And we say there are two types of nonce. So nonce, the first nonce is a counter that indicates the number of transactions sent from the account. This ensures the transaction are only processed once in contract accounts. So this is the number that represents all the number that represents the number of transactions that you have made. And then we have the balance, the number of WEI or ETH owned by that particular address. Then we have code hash. This hash refers to the code of an account on the Ethereum virtual machine. That is the 08 something. That is the code hash. Ethereum virtual machine contract accounts, and it also has it's associated to a private key. It has a private key. So all such code fragments are contained in the state database under their corresponding hashes for data retrieval. This hash value is known as code hash. For externally owned accounts, the code hash field is the hash of an empty string. So then we have the storage root, sometimes known as a storage hash, is a 256-bit hash of the root node of a Marco Patricia trie that encodes the storage content of the account, a mapping between 260 integer 256-bit integer values encoded in the trie as mapping for the Keka 256-bit hash. So this is just another hash which is connected to the Marco root of Patricia trie. So yeah, you can defer to the previous note and learn more about the Marco tree and Patricia trie.
Sure.
Yeah. Then we talked about what is a transaction. So a transaction is a signed data package that stores a message to be sent. So that a transaction contains six elements or components: the receipt of the message, signature identifying the sender, the value of the message, an optional data field which can contain the message sent to a contract, a gas limit, and a gas price. And also we differentiated a transaction from a message. And the only difference is that a message does not have gas price. Then we defined what are blocks. This one we had already seen from our previous demo of the blockchain. So blocks are bunches of transactions with the hash of the previous block in the chain. And we saw how people cannot be able to invalidate a block. So if you invalidate the first block, then you have to mine out the other transaction. So if a malicious participant invalidates one block, then they will have to go mining all the other blocks to make it light, which is a very tedious work to do. That's what makes blockchain blockchain secure. Think of the way people are able to change one transaction in a bank account. The cashiers are able to change or alter the ledgers they normally have. But if it was in blockchain, they will have to change the entire ledger. So you see that is a tedious work, and that's why we the same case for blockchain for the other database. So today I was doing some coding using MongoDB, and then I can show you something like that. So I'm creating a delivery app, and if you have access to this database, you can actually come and change the specific records of a particular person. Like, let's say, users, like this particular document, you can come and edit. So you can edit this one to false if you are a malicious actor. And then you update. So you have actually changed this document, but if it was in blockchain, you will have to change and then create a new hash, because you are updating. You will have to change and create a new hash. Then everybody in the network will be able to know that you have changed these records. But in the current systems that on Web3, people can be able to change. And if you have access to the server, if you are a hacker, and yeah. So those are some, that's how blocks now works. That's how blocks work. And yeah, so that's what we defined blocks as, and how we saw how blocks are mined and how they are hashed. Yeah. So today's for today's class, we will see the Ethereum ecosystem. Learn about we learn about the Ethereum ecosystem. And first of all, we can see, we will see how ETHs are created. So ETHs are created through mining. When miners validate transaction, 5 ETHs are awarded as not 5 ETHs, but the number of ETH keeps. A number of ETHs are awarded to miners. So initially, when the Ethereum was being created, they had a roadmap, and they had a pre-sale of about 60 million ETH. That is 7.26 billion. So 20% of ETH were for development fund, and 80% for Ethereum Foundation contributors. And then 5 ETH as mining fee. So these 5 ETH are for miners. Yeah, so this is how they distributed the Ethereum when they started creating. So from here, you can see the Ethereum historical prices. So you can go to this link. Hello?
Hello, I'm with you.
Okay. Okay. So you can visit this link and see the different and see the price growth of Ethereum. So this one was recorded a few years back. And then this is the ETH supply growth chart, how ETH distribution has grown all the way. So at the time it was at 105 million. So you can also visit this one to see the growth. You can also check this to see the growth. Then this is the Ethereum historical market capitalization chart. This one you can also find it on under Ethereum, etherscan.io stroke charts stroke market cap. Also, you can there are other. You can find the history of the current trend of Ethereum on CoinMarketCap and CoinGecko. Then we saw the ETH denomination. We saw who uses ETH. We also saw why you would want to use Ethereum. And we saw the application built on Ethereum and companies that are starting to accept Ether. So today we will learn about Ethereum ecosystem. So Ethereum ecosystem is, they have an application called Geth. Geth is the official client software provided by the Ethereum Foundation. It is written in Go programming language. So when the Geth client daemon is started, it connects to other clients and downloads a copy of the blockchain. So this is what I was telling you about yesterday. I tried I downloaded Geth when I started developing, and every time I would open the application software, my computer would start syncing and the nodes would not end. So it was like downloading the entire blockchain, and my hard disk was getting was filling up. Yeah. So as you can see, this is how the Ethereum network looks like. This is how the Ethereum network looks like. So every time if you have installed Geth, the blockchain will be downloaded to your machine, so that you have the current or the recent blockchain, the recent records of the blockchain. So it will constantly communicate with other nodes to keep its blockchain copy up to date. Someone can be able to mine blocks and add transaction to the blockchain and validate and execute the transaction. It acts as a server by exposing APIs to be called through RPC. So RPC, I know you know what APIs are. So APIs are application programming interface, and they are also sweet because other programmers are able to like consume them. Yeah, that's the correct one, because the front-end developers are always like, I want to consume your APIs. So for front-end developers, APIs are very sweet. So RPC is RPC.
Remote procedure call.
Yeah. They I'm looking for its what it represents, full meaning. So yeah, it's remote procedural call.
If I'm right, remote procedure call.
Yeah. So is when a computer program causes a procedure to execute in a different address or space, which is coded as if it were a normal procedure call without the programmer explicitly recording the detail for the remote interaction. Yeah. So most of these things you will be able to interact with it because you have to create an RPC when you are connecting to the Ethereum network. So parity
Okay.
is an unofficial. This parity is not official. Is not
Sorry, are you
official.
sharing this?
Or can you?
Excuse me.
Yes.
This
Oh,
the screen you have is still on just Ethereum. I'm not seeing the ecosystem
okay.
layout.
Sorry.
All right.
Right now you have it. Yeah.
All right. Great.
Yeah. So this get is the
Yeah.
official one. So parity, is it parity? Yeah. Parity is parity. So parity is a software stack that lets you learn blockchain based on the Ethereum virtual machine, and with a number of different consensus agents. That is, it can serve as a client for the Ethereum network as well as be the platform for you. So this client is not official. It is written in Last programming language and is maintained by a company called Parity Inc. The Ethereum, this is how it also looks on the Parity network. So it also communicates with the Geth, which is official, and then Parity console, Parity browser. You can be able to do the same thing, and then there is what we call Mist browser. So Mist browser is the same as almost the same as let's see if we can be able to get the link. Mist browser is a Mist browser is actually deprecated. It was deprecated. Can you see my browser?
Yes. You're downloading Mist. Yeah.
Yeah. So this is Mist browser. It's normally, you can also use it for coding. And yeah, the problem with it is also that it keeps on syncing your blockchain. It also keeps on syncing your blockchain, but you can also use it for coding. So I'll install it tomorrow so that I can be able to show you how it looks like.
Okay.
Yeah. So this one is used to browse the transaction on your local computer. So Mist is a concept browser that connects you with the Ethereum blockchain and uses P2P file transfer to access dApps. Yeah. So that is parity. So Get Console is a command line tool which connects to the learning node and performs various actions: create and manage accounts, query the blockchain, sign and submit transaction to the blockchain, and so on. So the Mist browser is a desktop application used to communicate with the network nodes. Then we have a JavaScript library called web3.js. So this is how you can be able to communicate with web3.js. Web3.js, let me share the documentation of web3.js. Okay, so web3, web3.js. So Web3 is the one which is used to connect with other blockchains. So this is like a snippet of how you can connect to Web3. So you initialize the Web3 as a package. You initialize the normal way we do on Node.js. Then you after initializing, you call it as a function, and then you give the URL of your blockchain. So this is how you can be able to connect different blockchains. But that is Cero, Solana, Avalanche. It's the same way for everything. So this is something that you can. Not sure why this link is not going through. So I'll share this one also, the docs on the chat. This will go a long way when you have completed your your smart contract and you want to connect it into a dApp, you want it to be consumed for front-end, you will be using web3.js. So web3.js is a JavaScript library that can be used to interact with a node in the Ethereum network, not just Ethereum network, but other blockchain network. So so as you can see, this is the Geth client, the official software that you can use. You can connect to Ethereum network through Mist browser. You can use Geth console, and you can use web app using web3.js. So this is how browsers and how you inject web3 so that you are able to use Metamask and the smart contract on your browser. So this is what normally is triggered, or that which is used to connect to your to the blockchain. Yeah.
Okay.
So interaction with an Ethereum node can be performed via the Geth console, Mist browser, and the JavaScript library called web3.js. Since it is a JavaScript library, you can use it to build web-based dApps. And then we have Solidity. Solidity is the most popular programming language used to write Ethereum smart contract. So Solidity is the most popular programming language used to write contracts and to learn on the Ethereum blockchain. It is a high-level language which, when compiled, gets converted to EVM bytecode. There is also a very nice browser-based IDE called Limits, where you can write your contracts, compile, and deploy to the blockchain. So this is the link for the limits. I think I shared in the previous class. I'm going to share it again. Yeah. So this one you can use it for writing your codes and deploying your codes to the Ethereum blockchain. So this is how limits look like, and we saw. So today we will deploy a simple smart contract. So Limits is a browser-based IDE to write contracts, compile, and deploy to the blockchain. So this is the old version. This is the old version. The new version looks a little bit different. And yeah. So then we have Truffle. Before we started the class, I was telling you about Hard Hat and Brownie. Yes. So they are frameworks. They are frameworks. So Truffle and Embark are the two most popular framework used to develop dApps. So Hard Hat, I heard about Hard Hat this year actually. So I never knew. I only knew Truffle. Truffle, because most blockchain are used. Celo uses Truffle. Avalanche uses Truffle. Most blockchain are using Truffle and Embark. So just the other day is when I heard about Hard Hat. So just like you have frameworks for web application development, such as Ruby on Rails, Python, Django, React.js, Angular, Vue, we have Truffle and Embark are the two most popular framework used to develop dApps. They abstract away a lot of complexity of compiling and deploying your contract on the blockchain. So they help you create smart contracts and without having difficulties. Yeah. So this is generally how it looks like when you are developing using Web3. So we have command line terminal, and then we have node.js console using Web3 or Web3 on the other side if you are using HTML. For this particular application, this one can be, you can use Node.js and React or any other framework to create the client side, that is the user interface. For this other part, you can use Web3.js to basically have a HTML or a CSS, the normal Web2 application. But in the backend, you have Web3, and then we have the RPC for connecting to the Ethereum blockchain. And then here we have the Ethereum virtual machine, and then we have the blocks in the EVM. Yeah. So, and then we have the blockchain test RPC. So the blockchain test RPC is the networks that I spoke about yesterday. So we have a test net, and then we have a mainnet. So the RPC, you can use it to connect it to different networks on the Ethereum blockchain. Yeah. So that is Truffle, and then we have Metamask. So Metamask, we saw Metamask have different is a wallet that you can use to interact or trigger transactions on the blockchain. So Metamask is a Chrome plugin used to interact with the Ethereum node. So they have a Chrome, a Mozilla plugin, and also Brave browser plugin. I don't know whether they have Opera plugin, but they must have an Opera plugin. So it is unrealistic for everyone in the world to learn a node to interact with the blockchain. So the folks at MetaMask host a number of nodes, so you do not have to. So all you have to do is install MetaMask, and it automatically connects to their node, which in turn connects to the Ethereum Geth node. So this is how it looks like. So they have parity MetaMask owned. This one is Geth MetaMask owned. So this is for Chrome browser plugin. This is Chrome browser plugin. Also, you can equate with the browser you are using, and then you are able now to communicate to the Ethereum Geth client. So they have the node which connects all through. Yeah. So since sometimes another disadvantage is that when you are creating a node, it's expensive. You need special hard disks, that is the SSD, and you also need a cooling system. So this is what they call leaks, the leaks which are normally used for mining, and so you need a dedicated machine, This the computer that I'm using cannot and was not intended for that purpose. So you need a general purpose, not a general, but a specialized server that does that work all day. And then you need power that is always constant. Because one thing, because if you have a blackout in your area, then it means that those machines won't be validating. So you need power that is continuous every day. It's available every day, and for most of us here in Africa, we normally don't have that power. So that is MetaMask, how it works, and yeah. So then we have the ENS. ENS, Ethereum naming system, is the DNS for the Ethereum world. Just like you map an IP address to a human readable name, you can map any Ethereum contract or wallet address to a human readable name. So for like this one, we have an example of an IP address, which is registered to google.com. Instead of typing the IP address in the browser, one can type google.com, which revolves to the IP address. So for example, these are someone address is a wallet address. With DNS, one does not have to memorize this address and can use alice.eth instead. So this is what I was telling you, that you can customize your own address to maybe abros.eth, and then that comes at a fee, because the Ethereum naming system is something that is being that is another ecosystem, not another ecosystem, but is a business or some or service the Ethereum ecosystem is providing. Yeah, and then we have Swarm. Swarm is a decentralized content storage and distributed service for Ethereum. The blockchain is good to store small amounts of data. What if you wanted to store a patient record, a sale deed, or some large file which needs to be publicly timestamped? It is expensive and also not scalable to store a blob in the blockchain. Some is used to solve this problem. You can think of it as a CDN, a content distributed network, but instead of the entire CDN network hosted on one company server, it is distributed on computers across the internet. So this one, you can also put textile and Ipfs here. They are part of the Ethereum. No, they are not part of the Ethereum ecosystem because they are different companies, but you can integrate it. You can integrate them with Ethereum because they function as the same. They store large amount of files. So this is what I was recommending to Damaris. If she wants to store blueprints of buildings privately and in a way that they need to be time stamped, so that someone is able to know that this blueprint belongs to this architect or this designer, then she can use SOAM or IPFS or textile to do that storage. Yeah. And then people who are sharing that file, if someone shares or have access to your file, you will be able to know, and then maybe restrict them or fine them with a coin or something. Yeah. So yeah, just like you learn an Ethereum node, you learn a Swarm node to connect to the Swarm network. So when you want someone to use your contract, you have to give them the deployed address and the API. So this is now how you are able to consume the smart contract once you deploy the smart contract on the network. So when you want someone to use your contract, you have to give them the deployed address and then the API. So you get a deployed address and a JSON interface of the API. So application binary interface. Application binary interface is the contract interface similar to APIs. When you want someone to use your contract, you have to give them the deployed address and the API. So in the future, the API will be stored on the Swarm. So anyone can look up the API just by looking at the Ethereum address. Then lastly, we have IPFS. IPFS is a decentralized storage system. It is not related to Ethereum directly, but can be integrated with Ethereum. IPFS is much further along in code maturity, scaling adoption, community engagement, and interaction with a dedicated developer community. So most people don't know about Swarm. They normally use IPFS and textile. Swarm, I have never come across, I have never worked with Swarm, but I know it's something that is used for storage. So Swarm's core storage component is an immutable context address chunk store rather than a generic DHT, that is distributed hash table. You can upload to Swarm, use it as crowd hosting. In IPFS, you can only register and publish content already on your hard disk. The two systems are different network communication layers and peer management protocol. Swarm has a deeper integration with the Ethereum blockchain, and the incentive system benefits from both smart contract and the semi-stable peer pool. So these are how the, before we see how the diagram, I explain the diagram, let me show you the IPFS desktop application that you can use to upload those files and how, yeah. So let's, as we wait for it to open, yeah. Currently, there have been some upgrades to IPFS. Okay. Can you see the which screen are you seeing?
I'm seeing the browser could not connect to IPFS
Okay,
API.
okay. Okay, so you can see the IPFS. So this is the IPFS software. So you have your own files. Right now, my network is a little bit bad, but you can see, you can explore and see different peers, and these are your settings. So you can change. You can see the status of your files, and the status of the files that you have been able to upload. So currently, right now, I'm having a bad network because it needs some good internet connection so that you can be able to connect to it. But generally, it looks like that. The IPFS software looks like that. Though there are another way. There is a way you can create their code that you can use so that you can be able to like customize your application to use IPFS. Just the way Cloudinally, if you have interacted with Cloudinally, there are APIs that they have exposed for people to customize, to use them, to customize Cloudinally for their app use. Yeah, the same way you can do the same on IPFS and also Swarm and also TextStyle. Yeah. So let's go back to the diagram. I hope you can see the diagram. Yeah.
Yes, sir.
So so our diagram keeps on becoming big and complicated, and a little bit complicated, because now we have other tools and technologies that are now in the Ethereum blockchain. So we still have our Geth and our parity here. And then we still have our MetaMask. And then inside the Ethereum network, not Ethereum network, or the EVM, we have the ENS, Ethereum naming service, pointing to our address. So this one is for the users. Then we have our contract ABIs that can be connected to Swarm. So we have our contract here, and then we have Swarm here that can be used that can be integrated to our ABI, or that can be that is hosting our ABI, and at the same time you can use it to do storage of data. Then over here on the other side, we have Web3 and our web app hosted on IPFS. IPFS as a network. So it's able to communicate with our contract here while our app is being hosted there, when our app is hosted at IPFS. So you can also host, just the way we do server hosting on Amazon, you can do the same on IPFS. There is also a new platform that was launched this year, that is Moralysis by Ivan on Tech. Ivan on Tech is one of the guys who I really admire, and I've been watching most of his videos when I was getting into blockchain. So Moralysis, he is pretty much involved in that project, and Moralysis is a serverless platform where you can be able to like deploy your smart contract there, the same way as you can see from this diagram, that is IPFS and so on. So you can also picture Moralysis being part of here, Moralysis being there. Yeah, but Moralysis has a better way. They have an elaborate way of how they are doing things. So we have Whisper. Whisper is a communication protocol for dApps to interact with one another. Yeah. So this one is helping different protocols. Whisper helps different Ethereum protocols like the IPFS network and the Ethereum network and Swarm network to like interact without any glitches. Yeah. Then finally, we saw the comparison between Bitcoin and ETH. So this one is a way you can be able to like view the current market trades. How you can be able to view the current market trade of different cryptocurrencies. So you can visit this coin if you are a Bitcoin holder. If you are a Bitcoin holder or if you are a trader and you want analysis on how the market is like, this one can help you in analyzing and giving you a hint or a way you can be able to like invest your money, a way you can be able to invest. So they normally have, this screenshot was taken when the market was all red. I think it was a bear market. Yeah. Then we did a comparison about Ethereum. There are some few comparison I will add. So Bitcoin is the first decentralized cryptocurrency created in 2009. We all know that by unknown persons named Satoshi Nakamoto. Ethereum was released in 2015 by a cryptocurrency researcher and programmer named Vitalik Buterin. So currently he is 27. A decentralized programmable platform which supports dApps, distributed application, or decentralized application running smart contract using digital tokens. A cryptocurrency and a worldwide payment system. So this is what Bitcoin is. It doesn't have all these elaborate services Ethereum has. Bitcoin enables peer-to-peer transaction, purchase of goods and services, long-term storage of value. So Ethereum enables peer-to-peer transaction, can handle accounts transaction as well, store, execute newly coded programming logic. So then we have another difference is that Bitcoin deflationally by design due its limited supply. So these ones we saw, the supply cap of Bitcoin is 21 million. Supply cap is supply cap is 18 million every year. Total existing coins is 18 million BTC. So this one we saw yesterday, we saw during our other class, the differences. And then we have Bitcoin versus Ethereum issuance model. So Bitcoin issuance, these are graphs to show how Bitcoin and Ethereum are issued. So we have like, so we have the growth, the way the growth, the Ethereum growth, the maximum growth of 18 million ETH per year. So we see that during the halving, Bitcoin's the supply of Bitcoin supply reduces. So yeah. So this one, I spoke of coin market cap. So coin market cap is a place, it's like NASDAQ, where NASDAQ is the world platform where you can register your market or your company shares and sell them to to the general public. So we also have market capitalization, where people can be able to see the current trades of each and every cryptocurrency. So you can visit and see the top 100 cryptocurrency. They normally have a trade. They do have a trade like a 24-hour volume, circulating supply of different coins, change in 24-hour price graph in 7 days, and market capitalization and the price, the current price in the market. So this one I spoke about it yesterday, that Ethereum is switching to from proof of work to a proof of stake. Yeah. So we in Bitcoin, we only have one account that stores the funds and the related code. Consensus algorithm is proof of work. Mining reward is 12.5 Bitcoins per block. So mining reward is 5 ETH per block. And transaction fee is optional. Transaction cost based on operation. Transaction cost based on size. So this one is cost on operation and storage. So the greater the storage you have, because of maybe if you're installing a movie on Ipfs also, then the operation or the transaction cost will be high because you're saving up for the space. Yep. So let's go ahead and see if we'll be able to deploy a smart contract today. So let me head over to limits. Limits ID. So limits is a okay, I'm sure. Then yeah, I'm sure. So this is the new IDE for the browser. You can actually switch to the old one if you're used to the old version. So I'll share this code on the, don't know if the chat will be, if I will be able to like share this entire code, so that I don't know whether
So we need to download the remix, right?
No, you don't need to download limits IDE. You just need to Google it. Let me share the.
Okay.
Let me share the link. Let me share the link. You just need to like visit that link, and then there are some plugins or some plugin that if you need them, you will initiate. So we have we have GitHub. It's connected from GitHub. You can load a contract from you can load the contract from GitHub or Swarm or IPFS or in HTTPS or GIST, yeah. Then here you can create a new file. You can open a file from your desktop, and then you can connect to a local host. Connecting to a local host means that you are connecting to Ganache, the one that I was showing yesterday as a local network. Yeah. Then we have featured plugins. We have Solidity, we have Run ETH, we have Solid Linter. This one is for linting, just like Prettify used in Node.js, or this one links your code. It makes, then we have Sourcify, and then we have Debugger, and then we have other. And then we have other plugins. So we have more plugins here. So these more plugins, if you want to like create in other systems, like if you want to connect to other system like Zero, like Avalanche, Sol. If you want to activate them, if you want to do more, you can activate them there. But generally, the ones that I will want us to activate is Solidity, and then this one for deploy. For the so we even have hard hat we even have hard hat provider. You can also do something with DeFi tutorials, and then we have DeFi Explorer, so you can activate them depending with the kind of a smart contract or project that you are creating. You will initiate this plugin depending with your project. So then, yeah. So from this part, you can create a folder here. From here, you can create a folder that you can use to store all your code. So we call this folder ADS. And remember, once you close this browser, once you close this tab, that contract is destroyed or lost. It's lost because so you need to save it in your local
Okay.
system. Yeah. Then from this folder, you need to create a new file called ADS first contract. And then the extension name of the contract should be SOL. Normally we light the best way to light the best or the best practice or industry's practice is to always start a file name with a caps, light it in capital letter. So it will be hello contract. Hello contract. So hello contract. So hello contract dot SOL. SOL is the extension for Solidity.
Solidity.
Yeah, extension for Solidity, just the way we have .oc for document and .pdf for PDF for PDFs. Yeah, and then yeah, so that's how that is your default workspace. That is your workspace. So once you have created the file, you will have a blank space. So this is where you write your work. This is where you write your code. That's where you do your work. And then we have the Solidity compiler. So I hope you from home, this is the Solidity compiler. I hope you have initiated that one or activated that one. So Solidity compiler, we have different compiler versions. We have the current version is 0.85. But I normally like using an older version of compiler, like 0.5, so that your contract code can, the way in Android people select, they want an application that covers from maybe Jerry Bean all the way to Lollipop and the current version of Android. So the same for Android compiler. If you want your contract to run in different compilers, then you will have to select a later version. Or if you are familiar with the current system, you can use the stable local version, that is 0.84. So for our contract, we will use a lower version of compiler. And then language, for language, you will select here Solidity. And then compiler version, you will select the default. So there are different EVM versions from where you want to compile. So you compile. So we have the one in Berlin, we have another one in Petersburg, we have one in Constantinople, we have others. So normally use the default compiler, and then you can auto compile your code. You can enable optimization. So all these configuration that we are seeing, we are doing. Remember, when you are deploying, you will also have to do the same while you are deploying. And then you can hide. You can either wish to hide warnings, because warnings are just they are just warnings. They are not errors in your code, because the contract will always work. So I'll go step by step explaining what different lines of code do. So we have the first one. We have the first line of code, that is Spdx license identifier, which is for OpenGPL. Your contract, you can decide not to use a license, but it will, the code, your program will have some error, so you can indicate no license. Yeah, and this it's commented, so it won't be learned. Then we have a comment. This is how you write a comment in Solidity. So
Java.
these are, yes. Hello.
Hello, I'm with you.
Yeah, so this is how you write a comment on Solidity. It's the same way in JavaScript. You can have multiple comments like this. These are multiple line comment. So with other stars. So these are multiple line comment, and then your comments there. So comments are generally good for you, because you want to leave comments on what different lines of code I'll do it. Yeah. Then we have Pragma Solidity. Pragma Solidity indicates or specifies the compiler version that you want. So the way we write it, we normally write, you have to use a greater or equals to this version of compiler from here. So it has to be equals to 0.6 or greater, extending all the way to 0.9, less than 0.9, because currently we don't have 0.9. We don't have 0.9. So it has to be less than 0.9. That's how you specify, or you can leave it like that. You can remove and leave it like that, and don't forget to add the commas. You can leave it like that, or you can light it like that. So it's always good to kind of light it like that, because the system will learn in it will be able to learn in different compilers. Your code won't have problems with compatibility issues, unlike when you specify one compiler, because when you deploy, then the contract has to use the same compiler in either scan. That means maybe the compiler version may end up being deprecated or something, because as you can see, some of these compilers are very old, and then the Solidity language keeps on being upgraded. So you have to like cover a wide range of compiler. Yeah. Then the contract now we come to the body of the contract. So the contract is written like this. We have contract hello Africa with curly braces. That's how you write the contract. So every code that you have written will be obtained in this, will be inside these curly braces, will be inside these curly braces. So everything that you will be writing will be inside these curly braces. So anything else outside here that is not part of your contract won't be part of your contract. So you can write other contracts. You can write other contracts here, like hello ADS. You can write other contract inside the same the same contract. Yeah, and then you can see that these contracts are being compiled automatically, because we selected auto compile. Yeah, so we have the variable declarations. So variable declaration is done after the contract name. So here we have the variable declaration. So we declare variables. We have different types of variables. We have a string, we have string, and we have uint. In this one I've written two variables to get us started. So I have a string, which one is private, and the other one is just a string without any definition. And then we have another one which is private. This means that this variable can only be accessed privately within that smart contract, not outside the smart contract, but the message can be outside. Then we will have the functions then, or the getters. So we have the hello Africa, or hello. These are we have the setters. Setters are functions that are used to set different parameters on your smart contracts. So this function sets the username with a string memory, creating a new user. So this is the memory allocation that I was saying about, that you have to pay for this memory allocation when you do that. So, and then so these keywords are reserved for memory, is reserved for storage. Public can be accessed publicly by anyone. Yeah. So after we compile, we will go to our deploy and learn transaction. So under deploy and learn transaction, we have environment of the EVM. So we have the virtual machine in Berlin or London, or we can inject Web3. That is if we want to interact, with Metamask. If we want to interact with Metamask. I hope you did the fund my ETH tweet. Then, but that won't be much of a problem because we also have other accounts here. So we have an account here that is already funded with 100 ETH. This one, we will be using it for development. And then we have a gas limit, and then we have a value, and then we have a WAE. And then here we have a contract, our contract that we have created. And then this is our contract name is Hello Africa. And then it's in the ADS folder, hello contract.sol. And then we have deploy, and then we have publish to IPFS. So if your contract is going to interact with IPFS, you can deploy it there. And then we have at this specific address. So we can copy this address here, up there, and then paste it there. And then we deploy. So it will be deployed, it will be. Hello? Can you hear me?
I can see. Okay.
Yeah, so if you can see my screen, sorry for the interruption. So if you can see my screen, this address is the one we have used to pay for the deployment. We have used it to pay for deployment. And if you can see, we have kind of used like 1 ETH. So it's 90, not 1, but 0 point something ETH. That's why it's 0.0, that's why it's 99.999. So we have kind of used 0.0001 way to deploy this particular contract, and it has.
Sorry, question.
Yes.
The account is on. You have to log into your MetaMask to get the account.
Limits already have provided it. Limits have provided it. Okay. Limits have already provided it, but we are going to use MetaMask if we want to deploy this contract to the real to the test to test network. If we want to deploy it to test network, we have to inject Web3 here, so that MetaMask can be initiated or not initiated, but triggered to deploy the contract to test ethers, yeah, through injecting Web3. But if you are using the JavaScript VM machine in Berlin, this one will come with its own account already provided here, yeah. And then at deploying, we will create at address at this one. We'll copy this one. And we will pay for deployment of the transaction, for deployment of the contract. So once we deploy, the contract will be deployed here down. So you can see deployed contracts, and then we have transactions recorded. So below here, we have like the terminal for you to see what the transactions that you have been able to make. So the first transaction that we have made is deploying the contract, this one. So the transaction has this hash that we talked about, transaction hash, status, transaction mined and executed successfully. And then we have the hash, we have the input, we have from this address, this particular address over here, and then to this contract, So this contract has come up with its own contract. This is its own address, the address that I was saying about contract addresses, and this is the externally owned accounts that has triggered this transaction or has triggered the deployment of code. So from here, we have this function, which is a setter. A setter is this one is like an input function that is used to help you input data. So from here, we need to set our name. We need to set our name. Right now, in default, we have already put a variable here. I'll create another function as getter. I will create another function which is a getter. Getters are used to get information, and then in default the username is Jordan, but with a setter we will be able to change this name to now your name. Let's say we want to set Ambrose as the new username. So we will do a transaction, and then we will be able to pay. So we will see our ETH drop again as we do this transaction. So you have created another transaction. You can see the record has updated. So let's go to the other transaction. So this one, we have triggered the setter or the function to set username. This one, as you can see, the transaction is pending, but it has been verified below here. So the transaction, this one, you see, we have triggered the function set username, and then we have been able to set the username, which is a string, and we have paid some few gases. We have paid gas fee of yeah. So here we have decoded inputs. As you can see, we have been able to set the new name as Ambrose. So we will create another function, because this way is not a good way to like display the that we have been able to change. So we need a more friendly way to show that we have been able to change the data. So we will create another function. Let me just copy because of time. Function get username. Yeah. So function get username. This is a getter. This one is a getter, and it's going to get the username. So tomorrow we will do more on this. So tomorrow we will do another. You can do on your free time. You will be able to like do. You will be able to set a string message, and also private age. You can create a setter function for age, and create a message, a setter function for message, and also a getter. So we will go back to so we will go back to our code and compile again. This is auto, but we will have to deploy again because these changes have not been registered. The function that we have added has not been registered. So we will go again and do deployment at the same address, and then we have deployed the contract again. And then now you see the changes have been updated. So since we are using the memory, and we had already set the username here as Jordan, if we do a get, you'll see that our string is still Jordan. But if we do an upgrade here, the same thing we have done, let's add your name again, Ambrose. And then we set the name. And then let's see if the contract has yeah. So the transaction has gone through. And then if we do a get again, we see that the name has changed. Yeah. You see that the name has been updated. You see? So that's it for creating a smart contract. So this one will dive deeper. We will dive deeper into smart contract. This is just a basic. We will dive deeper.
Your screen is not showing.
So Julian, in our next topic, let me share what we will be expecting.
You're not sharing your screen.
Let me share. Sorry for that. So in our next lesson, I think it's next week. That is lesson 4. So lesson 4 we will learn about cryptography. Yeah, lesson 4 we will learn about cryptography. That is next week. But I felt like I really wanted to start introducing a bit, bits by bits. So in next week, I felt like I wanted to start introducing smart contracts bit by bit. So by the time that we are doing smart contract, we already know the basics of smart contracts. And yeah, if this yeah, that's what I felt like doing. So yeah, so that's what you'll be expecting next week. I'll share this code. I'll share this code on the chat. I think, yeah, on the chat. I don't know whether it will be copied the whole of it, or I can share the entire file.
Maybe share the entire file.
Let me just share the entire file. Let me save it, and then we will also learn about this metadata and this .json, what it does. Let me just copy this one, and then I'll share the entire file on the group. And then you can try on your free time how to set a message, and you also set a function to set your age. Yeah. So you set a setter, and you create a setter function, and then you create a getter function. Yeah. So I'll share that code with you. So yeah. Any question at this particular time? Yeah.
Well, no question. Everything is becoming interesting, and more of we're not diving into programming.
Yeah. We are not diving into programming, and things will get even interesting when we get to lesson 5. That's when we will do smart contracts. Yeah, that's when we will do smart contracts. Yeah. So I didn't want to like do something more because Damaris today is not with us, and yeah, I want everybody to be on the same page. Yeah.
No, it's okay.
Yes.
Yeah, no problem with that.
Yeah. Yeah.
I wish you
But
the file.
yes.
Okay.
Okay. I hope you will try, and also don't forget to get test ethers. Don't forget to get test ethers. I shared the links for yesterday to get free test ethers. Yeah, if you are unable to do so, I can also share with you some test ethers because I have a lot. Yeah, so I can share with you so that when it comes to contract deployment, we will be able to have a smooth deployment. Yeah. Yeah.
Okay.
Yeah. So awesome, and have a nice time.
All right. Yeah,
Yeah.
it's okay. Thank you very much.
Yeah. Have a nice evening, and yeah, take care.
And you too.
Okay. Bye.
Yeah, bye.